In this tutorial, we shall learn to import 3D geometries which are modeled externally and imported into SOLIDO in STL format. Corresponding exercise files related to this tutorial can be downloaded from the link mentioned in the comments below. Once you open the new project in SOLIDO, you will need to save the file in the same folder where STL files are located. Then at the block window, under Type, change to STL. Double-click on the STL file input. Now we can browse and load the STL file. You can observe a number followed by an underscore as a prefix before the file name. Once you choose the file and click on Open, we see the STL is imported and the color is assigned automatically as per the color database. If the STL file name doesn't have the color number as a prefix, we have to input the color number which represents its material or boundary condition properties manually. In fact, we also can load multiple STL files together. Double-click on the STL file input, then multi-select all the STL files holding Shift or Ctrl-A, then click on Open. Now we see that all the STL files are imported as a new block. If we toggle Enable from Yes to No for any block, then that STL file is hidden and eliminated from the analysis. It is recommended to prepare an STL file using the principle of superposition. We will discuss various tips and tricks which speed up the process of making an STL file in a separate tutorial. Now once the STL file is imported, we need to rearrange them as per priority, as SOLIDO reads them under the principle of superposition. If we click on Fill Blocks to triangulate, we can't see the facade bracket as the insulation has higher priority. So we will select the first 5 blocks using the Shift key, then click on the last block as a reference point. Then from the block menu choose Move Selection After. Now choose Fill to triangulate the mesh to visualize the result. We can check if the boundary conditions are applied correctly by clicking on the BC icon and visualizing the output. Here the boundary conditions are modeled as a block and imported as an STL. Note that as per EN ISO 6946, the highly ventilated cavity behind the cladding is modeled as the third boundary condition. After importing an STL file, it's advisable to go to the minimum grid. This makes a box around the model. An STL file has no dimension, so, using bounding box created by minimum grid you can check the overall dimensions. If in case you need to change the units, go to the Settings menu and choose Coordinates. Here you can update them. Now we need to generate the grid as the imported STL geometries are not yet linked to the grids window. There are several ways to create an optimized grid. However, in this tutorial we will use the standard auto grid generation. From the Grids menu choose Auto Grid, then input the settings as shown here. Merge meshes smaller than 0.1 cm, for smaller meshes up to 5 cm, the split distance is 1 cm, and the splitting ratio is 1.3. We shall talk about each of these parameters at the next tutorials. Then click OK. We now see the grid generated for calculation. The process undergone for the command auto grid generation is also explained in detail in the next tutorials. Now we click on Calculate, which automatically generates meshes from the grid and runs the analysis. We shall now try to modify the geometry using transformation tools. Suppose we wanted to copy and place another T-profile beside. Select the block under the list, then from the Blocks menu choose Copy After. Now the block is duplicated overlapping with the original block. Now we need to move the copied block. From the Blocks menu choose Transform Coordinates or you can directly enter Ctrl-F. From the Transform Coordinates window, choose Translation as we need to move the geometry. You can see from the image window that red represents the x-axis, green represents the y-axis, and blue represents the z-axis. This is also reflected in the titles in the grid window. In our case, say we need to move 20 cm along x-axis. So we enter 20 at x input. If you want to move in the opposite direction, you can enter a negative value like -20. Once the STL is at the correct position, you can save the SOLIDO project and you will be asked if you want to save the copied geometry as a new STL file. If you choose yes, you will see a new file saved in the folder STL located with a suffix _t. If you toggle Enable to No, then you will not be reading this STL file for analysis. In this way, you can read multiple STL files and choose which to use while performing analysis or parametric studies. For our exercise, we don't need the copied T profile for the analysis. So, we eliminate this block by toggling Enable from Yes to No. In this tutorial, we learned how to import geometries into SOLIDO from STL. In the next tutorial, we shall learn in detail how meshing is performed for the files imported from STLs. Thank you for watching, see you in the next tutorial.